This video, we're going to talk about what is the power set of a set. So here's the definition. Let A be any old set. The set of all subsets of A is called the power set of A. And we'll typically denote the power set depending on by what book you're looking at, depending on that. Some books like to use like a fancy P with like an A inside of parentheses. It's kind of like some kind of function notation it reminds me of. So P of A, that's the one I'm probably going to use. Another book likes to use, or some other books I should say, like to use this exponent notation like 2 to the A. Either one of those, again, they denote the set of all subsets of A. So the power set's a little bit goofy because it's a set of sets. So let's try to get more comfortable with what the power set actually is with some easy examples. We'll do the first one as an easy example, but then the second example I do is a little bit more tricky, and you'll see why, so stay tuned for that. So the first one though, let's do an easy one. So A is the set 1, 2, so the set with 2 elements in it, and I want to figure out what's the power set of A. So again, what are all possible subsets of this set? Now, over here to the side, I'm going to get these two out of the way first. These are sort of the free ones that you'll see. So what do we know is always true? I know that the empty set is always a subset of A. Therefore, the empty set's in the power set of A. Similarly, I know I can consider A as a subset of itself. Therefore, A is in the power set of A as well. So those two are free. They will always be in the power set of A. Now let's go to the ones that are a little bit more dependent upon, like what do the elements of A actually look like? And so here, I'm just asking, how many other different subsets can you make if you're only allowed to pick from these two options? Okay, so 1 is an element of A, and 2 is an element of A. Remember, that's what the little E symbol means. But if 1's an element of A, then I can make the subset that just has the single element 1 in it. So the set 1 is a subset of A. So notice, when I have an element, then if I put the little squiggly brackets around it, that set is a subset of A now. Similarly, the set containing 2 should be a subset of A as well. And therefore, I just want to translate this. That tells me that the set containing 1 is an element of the power set. And the set containing 2 is an element of the power set as well. So I hope that you see that kind of work through. You identify, okay, here's this element of A. Then the set containing that element is a subset of A. And an equivalent way to say that is that the set containing that element is in the power set. It's an element of the power set. And we'll do some more examples in case that was, clear as mud. So therefore, though, there's really not anything else you could do. So the power set of A, it consists of these 4 elements. And again, we said the power set's kind of goofy because the elements of the power sets are sets themselves. So the elements of the power set of A are the empty set, the set containing 1, the set containing 2, and the whole set A. Let's do a trickier example. So, before we do that though, this just has to do with the fact that, again, we know that the empty set is always a subset of A, or maybe a better way to say that. The empty set is a subset of all sets A. And an equivalent way to say that now is that the empty set is an element of the power set of all sets A. All right, now let's do that tricky example that I've been building suspense for. So look at this A. A consists of, there's an empty set in there, what the heck? And then there's this set containing 1 in there, my goodness, and then there's this element 2. And again, same instructions. I want to compute what the power set of A is. Well, let's start with the freebies. I know that the empty set is in the power set, and I know that A itself is in the power set. But do not be confused. This empty set right here is not at all referring to that one right there. My goodness. So what's going on here? Now let's talk about what's actually in the set A. So the empty set happens to be an element of the set A as well, right? He's right there. So the empty set happens to be an element of the set that I'm playing with. Similarly, the set containing 1 happens to be an element of the set that I'm playing with. And then, 2 is an element of the set I'm playing with as well. But I want to try to go through this same logic where I've identified what the elements are, because from there, I'm going to think about, well, what are like the 1 element subsets that I can make with these? Okay, so if the empty set is an element of A, starting over here on the left again, that tells me that the set containing the empty set is a subset of A. So again, I should put squiggly brackets around it, and the little E symbol changes to a subset symbol. Great. Similarly, the set containing 1 is an element of A. That tells me that the set that contains the set 1 is a subset of A. And last, if 2 is an element of A, then the set containing 2 is a subset of A. Last thing here, for this little part anyway, is to just rephrase this. If the set containing the empty set is a subset of A, Another way to say that is the set containing the empty set is an element of the power set of A. Similarly, the set containing the set 1 is an element of the power set of A. And finally, the set containing 2 is an element of the power set of A. And so what have I got so far? If you're following the things I'm coloring, I'm trying to color in what are the elements of the power set as I collect them. And what else do you see? My set A only has 3 things in it. And so far, I've kind of got the 2 extremes. What if I picked nothing? That's the empty set. What if I picked everybody? That's A itself. And now I'm kind of working my way through, well, these are all the different ways I could pick one element at a time. And really the only thing left to do would be how many ways could you pick 2 of them at a time and list those out. So finally, we'll compute what are the 2 element subsets that we can make from this list, or from this set, I should say. That's again my set A, empty set, the set containing 1 and 2. So what would it look like if I pick 2 at a time? Well, I could do the set that has empty and the set 1. So if I pick those first 2, so that should be an element of the power set. What if I pick the empty set and 2? So that should be an element of the power set. And the last thing, what if I picked the set containing 1 and 2? And so that would be my other 2 element subset. And so if I throw all of these purplish colored things together, I think you see that you get 8 of them. And if I throw them all in, thus the power set of this particular A consists of the following, and I'll try to squeeze them in. Empty set, A itself, and then I have all like the singletons. When I say singleton, I mean a set that contains 1 element. So the set that has the empty set, the set that has the set 1, and the set that has 2. Now I'm going to try to squeeze in the 2 element subsets. So, and I'll just do that below, but I just didn't have enough room to list them horizontally. Not trying to come up with some crazy new math notation there. Just still listing the subsets. So what do we got? The set that has empty and the set 1, the set that has the empty set and 2, and then finally the set that has the set 1 and the element 2. So this is what the power set of A looks like in this example.